All right, hello everyone. My name is Taylor, and today I'm going to be doing a bit of a video on reading and writing C programs because one of the categories in Pico CTF is reverse engineering and buffer overflow, or not buffer overflow, I'm sorry, binary exploitation, which has to do with buffer overflows. But critical to understanding both of those categories and being able to solve challenges advanced level challenges revolves around your understanding of C programming and your understanding of assembly language. And the way to start learning, in my opinion, both of those things is to start reading and writing C and then develop a deeper and deeper understanding from that standpoint of different things like data structures, the compilation process, etc. There's a lot to learn. I think personally that reverse engineering and binary exploitation is one of the most technical um, CTF categories, or maybe hardest to learn, hardest information to gather. Um, but yeah, in this video, I'm going to assume that you have a bit of programming knowledge already. So I'm going to assume that you know what variables are. I'm going to assume you know what functions or methods are. I'm going to assume you know basic data types like strings. I didn't list here, but like integers, chars, or characters, etc. I'm going to assume you know what the terms taking user input and printing output mean. And I'm also going to assume that you know the modulo operator, but if you haven't, that one's not too hard. All it is the remainder instead of division. So if I did 2 um, or 10 divided by 2, that would give me 5 with remainder 0. If I did 10 modulo 2, it would just be the remainder after division, so it would be 0. And the modulo operator is not super complicated. But we are going to have to use it at the end of this video, so you might make sure that you understand it if you've never heard of it before. Um, yeah, so let's just jump right into it. So I told you that Pico CTF's categories are two of them are binary exploitation and reverse engineering. And they're mostly in C, and a knowledge of C will help you understand and solve problems in both of those categories. But I guess the question for me, at least when I started learning, was why do we even care about C? And what makes C so great? So first of all, the reason we care about C is because programs we use every day, most operating systems, databases, embedded systems, so like your microwave or I don't know, assembly line computers that do robot functions and stuff. And also interpreted languages like Python is an interpreted language, but what interprets Python code is a big C program. So lots of things rely on C, and lots of things rely on C that we use on a day-to-day basis that are critical for everyday life. Um, so C is used in everything, and it's what a lot of critical systems are written in. And most of that is because C is very fast um, and good at what it does. So furthermore, the reason that it's big in security is because C was not designed to be a secure coding language. So some research came out recently that said there are 15 bugs per 1,000 lines of code. And Windows is 50 million lines of code, over 50 million lines of code. So imagine how many bugs are in the Windows operating system. Some of these bugs, not all of them, but some of them can be exploited to allow a malicious actor or an attacker to take over the control flow of a program, execute their own code if they want to. Basically, what they can do is if they can exploit one of these software bugs, they can redirect the program to do something malicious. Um, and this is the start of an understanding of how you can be able to actually do that with an exploitable program, is learning to read and write C. So I have this chart here, bug feature by design, because a lot of us write bad code, but we try and ship it off as a feature. But yeah, there's lots of bugs. Humans make lots of mistakes. We're getting better at finding them with different languages like Rust that are coming out to try and combat that. You have to have, you have to prove that your software is secure and for it to be able to even compile. But it can be very complicated. So it's an ongoing area of research. Anyways, moving forward. So C has unique syntax. We use brackets and parentheses. It's strongly typed. Semicolons are the delimiters. So if you've ever used Python before, you know that you have to use tabs to indent after functions and if statements. In C, it's all revolves around brackets, parentheses, and semicolons. I don't know, my mouse is on screen. Hopefully it transfers in the recording, but you can see when you declare functions, you put the arguments in the parentheses, and then you have a bracket, then you have semicolons to denote end of line, um, and then quotes for strings, etc. So because it's semicolons, unlike Python, you can do your entire piece of code in one line. It has nothing to do with white space. So on line 19 here, you can see I have the start of the same function just in one line. This doesn't look very pretty though, so it's common coding convention to do it like this. So parentheses with functions, brackets to declare the start of that function, and then strongly typed. So if you've ever programmed in Python, which is what I'm going to be comparing most of these things to, um, you don't have to declare types when you declare variables. It's implicitly typed. The compiler determines the type of the variable um, by itself. The programmer does not have to do that. However, with C, it's strongly typed. So you have to say, I'm declaring an integer on line 4 here. I want to declare an integer called a and set it equal to 7. If I said I want to declare an integer called a and I set it equal to a string, so I set it equal to the string something, it would not compile because, of course, a string is not an integer. So you have to be very explicit with your types in C, which is another word for it, explicitly typed. You also notice, so we covered the brackets, the parentheses, semicolons, and strongly typed. But another thing about C is that it does not come pre-baked with lots of different functions. So on line 1, you'll see this pound include stdio.h. So that's standard input output.h stands for header file. So you can see at the top above line 1, this program is called if.c, and we're in the main function. This is VS Code I use for my editor. So the file is called if.c. So C is the extension for, a C program, and .h is the extension for a header file, which you can define different functions to use in other files. So you have to include this one, standard input output standard library, so that you can use this printf function on lines 8, 11, and 14. So you always probably have to use pound include standard input output.h when you write in C, and other ones as well that are more common, um, depending on what programs you're writing. So C does not come pre-baked in with lots of different functions, so you have to include them, include those libraries, just like in Python, except Python, like the Python ships with the print function, the input function, etc. But in C, those are not already baked in. Moving forward, format strings. This one throws a lot of people off sometimes. So if you want to print out a variable, you have to give C the format of the variable. So if you have an integer, you can see on line 15, I'm printing out an integer called number. And I'm going to actually print out the number 5. But to do that, I had to say, oh my goodness, quote, %d, quote, number. And the output of this on line 15 is just going to be 5. It's because when you want to print out variables, you have to use format strings. And then the numbers appear, or the variables appear in the order that they're entered in the printf statement. So actually, let me do something. I have this online C compiler that might make this a little bit more clear. So I'm going to declare a few variables. I'm going to declare an integer called a, set it equal to 9. I'm going to declare a char called b and set that equal to the letter b. And then I'm going to declare a double called c and set it equal to 10.75. If I want to print all these out, I'm going to use the printf function with my parentheses because I'm calling a function. And then I'm just going to make something up. But I want to print A, B, C. And to do this, I'm going to say the integer is A, is called A, and has a value of, and so then I want to actually print out the value of the variable. So I'm going to say %d because that's the format for an integer. And then I want to say B is, whatever. So %C. So I'm going to go back to my handy dandy chart here. %C is a character. I had it right. So %C, and then a double. Oh, what's a double? A float. Maybe a float will work. %F. And I got lazy on my thing. C is this. Okay. So now I have to list. So %D, because this appears first in the string, is going to be my first argument after what I'm going to print out. So I'm going to put A, and then this %C, which represents a character, because this is a character type, is going to be my second argument. So I'm going to say B, and then now I want to print out the double. So now I'm just going to say C. And we're going to run this and see if it works. Perfect. So you can see the output down here. Let me see if I can zoom in a little bit. There we go. Okay. So you can see down here, the integer is called A. So the integer is called A. It has a value of %D. But it didn't print out %D. It printed out the value of A because I told it that it's going to expect an integer, and then I provided it as an argument to the printf function. And so then B is B, because I set B equal to the character B, which might be a bit confusing. But a character type is only going to be one character, so it's either going to be A, B, C, etc. So character type, and then I printed it out %C, and then the second, since this occurs, it's the second format delimiter in the string. So %C is after %D. It's going to take the second argument after the string. So the first argument was A, which is 9, which we can see down here in our output, and then B, which is here, and then C is %F, which is for float. Double and float, I guess, could be used interchangeably because we didn't overflow anything. So we did, oh, it's actually LF for float. Well, probably doesn't change much, but let's run it again. There we go. Same output, but we put LF for float, or for double rather, because we declared a double. And then we provided it as the last argument, and it printed out that value as well. So that's kind of how format strings work. Hopefully it doesn't get too convoluted. All it is you enter the delimiter for the type of the variable. So like %D in our chart represents an integer. So we have %D for this integer A. %C represents a character. So we have %C for this character B, which we're giving in the function in the arguments after the string. And then we have %LF for a double, which we give as the last argument. So you just order them afterwards in the order they appear in the actual string. Another thing, this is a handy dandy tool, this online C compiler. There's also like online disassemblers and stuff that can be helpful in solving challenges when you get more and more advanced. Okay, back to regularly scheduled programming. So C has unique syntax. Just went over format strings. We've gone over parentheses, brackets, including libraries, calling functions, and semicolons, which is pretty much the basics of the language. If you want to know more, there is this book, The C Programming Language by Dennis Ritchie and Brian Kernighan, that is very famous. I think you could probably get an online copy, but this teaches you more than you would need to know to be able to do buffer overflow challenges. But yeah, sorry, honey pop up there, but this book would be very useful if you want to learn about the internals of the C language and how to write good, efficient C code. All right, actually back to our regularly scheduled programming. So common C functions. So in Python, we have print, in C, we have printf. I just kind of went over it. It does not automatically do new lines. So you'll need to add a \n if you want to do a new line. But it uses format strings and it prints out stuff to the console. So you can see in this snippet of code on line 15, we call the printf function that prints out the value of the variable a, which is an integer. So we use the %d to represent an integer, and then we provide it as an argument after the fact so that printf can print out the actual value. So this would output, this is the value of my variable a colon and then 6. So printf is a common function. And then we have scanf, which takes user input. So print out, scan in. So don't worry about the and sign on line 20. We'll go over that a little bit later. But when we want to scan in user input, we first have to declare a variable. So if we want the user to give us a string, so like a string of text, we'd have to declare a string variable. If we want them to give us a number, we'll declare an integer or a double or whatever type of number they're going to give us. And then we can provide that as an argument to the scanf function for what they're going to give us. So in this case, I printed out, please enter a number. And then I scanned in an integer, so I provided it as a string in the first argument of scanf. And then the number that they enter is going to get stored in this input variable. And then I'm going to print it back out. The user entered %d because it's an integer, and then I give it the input variable again. So this is going to populate that variable so we can actually use it in our program. And scanf is the function that does user input. Side note, something that's helpful about C, since I've been going off on all of this, you can just Google man scanf, and it'll come up with this. These nice man pages that give you a big breakdown of what these functions do. Actually, it might be man 3 scanf. I think I was already on the. Okay, either way, this is what you want. It tells you what you have to include to use the function, and then it tells you the different arguments you need. So, yeah, but you can see the arguments: constant char pointer, format string. So we give it the first argument here, the format string, which is just %d because that's all we're taking. And then the dot dot dots represent what arguments we want it to populate, or what variables we want it to populate. Let's see if we can find. Well, the example can be here. Okay, now back to the slideshow. So that's printf and scanf. So now I'm going to take you through writing a program to determine whether a number is even or odd. It's going to be a very simple algorithm. It only relies on the modulo operator, but hopefully this will give you a good understanding of what C syntax looks like, and you can watch me code it out myself. I've been writing C for a while, so you can kind of see how I do it. Once again, very simple program. It's not like you're going to learn the secret to anything by watching me, but you might have a good understanding of the syntax it takes to be able to do this. I would encourage you have all the information you need to be able to actually write this program by knowing these different syntax things. So with the brackets and parentheses, strongly typed, semicolons, blah, 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 and the include, that you can go to this online compiler. So onlinegdb.com/online C compiler, and you can actually do it yourself. So I would encourage you, pause the video, go here, and try and do it. And then come back, and I'll walk you through it. So pause, I'm going to give you 2 seconds. Okay, I'm moving on. All right, so to be able to do this, I'm going to delete that for a second. We already have included our center input output.h, so I don't need to worry about that. And all I'm trying to do is determine if a number is even or odd. So I can declare my number. So it's gonna be an integer. Actually, yeah, it's gonna be an integer because I don't like handling if it's a double and it's not if it's not a whole number, there's kind of pointless. So I'm just gonna call it an integer. And then now we need to, let the user tell us what number they want to determine is even or odd. So we need to use scanf. So I'm going to say scanf, and then I'm going to tell it what I want to take in. So I want to take in an integer, and then I want to fill it with the number variable. And so this this and sign, I said we're going to talk about it later, so you can kind of disregard it. But know that the scanf takes the memory address of a variable, not the actual value of the variable, so that it can write in a value. But don't worry about what that means yet. Just know that this and sign means we're giving it the memory address of a variable. So we're going to take in this number, and then now our variable is populated. So now number is going to be set to whatever the user wants it to be. So then once we take it in, we're going to say if, now we need to check if it's even or odd. And the way we're going to do that is modulo, using the modulo operator. So if we divide it by 2 and there is a remainder of 1, then it's odd. If we divide it by 2 and the remainder is 0, then it's even. Um, very simple algorithm to determine if a number is even or odd. So we're going to say if number, can't spell, number, mod is the percent sign, 2 is equal to 1, then we can print out printf odd, and then we're done. Else, there's only 2 cases, because when you divide by 2, it can either be remainder of 1 or remainder of 0. There's no in between. So we can just say else printf even. And that is our program. So I'm going to go ahead and run it. Oh, I did not prompt myself for anything. That's probably not great. So now I'm actually going to prompt the user, please enter a number to determine if it is even or odd, semicolon, and then I'm going to scan it in. Okay, now please enter a number to determine if it's even or odd. 9. It's odd. No way. Okay, let's exit the console. Let's run it again. Let's do 10. It's even. No way. Yeah, so that's a simple program. So you can see brackets on my function, semicolons, parentheses when I call methods, semicolon, more semicolons, brackets on my if statements, condition in parentheses. Yeah, when I don't have arguments or format strings, I can just do printf like that. Yeah, it's a very, very simple C program. And now you should be able to read C programs that use these features. There's also for loops. So like if I want to do a for loop, right? So for int I is equal to 0. So we declare our variable in the first, and then we put a semicolon. We can say I is less than whatever number, I is less than 21, and then our iterative thing, I plus plus, and then brackets. And then while is the same way. So while I is less than 21, and then we have brackets. So these are our basic conditionals in C. It all follows the same way. You have your thing, so if statement, for loop, while loop, then you could do like a do while loop. I never use those though. And then, your conditions in parentheses. So my for loop, I declare an iterative variable called I, and the for loop is going to execute while I is less than 21, and then I'm incrementing I by 1. So I plus plus just means I plus equal to 1, and this just means I is equal to I plus 1. These are all the same thing. Well, all these 3. But yeah, these are basic conditionals in C. And if you want to learn more, like I said, there's that book. There's also W3 Schools for C, where you can have a whole introduction. It can tell you differences between things like C and C++. Um, I can tell you the difference right now is that C++ is object-oriented, but then you can get started, you can do syntax. This is going over kind of the same type of stuff. It has exercises. So you can say int main, printf, and submit the answer. And then we get it correct. Perfect. This is a single line. Oh, comments, right. So comments can be double lines, or it can be, so double forward slash is a single line comment, and then, forward slash asterisk, and then asterisk forward slash is a multi-line comment, and I can do that here too. So if I hold control and do that, then I comment this out. But if I want to comment from here to here, I can do this and then that. And now this is all commented out. So yeah, there's more and more things to learn, and W3 schools will walk you through variables, data types, constants, booleans, if statements, switch statements, loops, all these things. And then we're going to talk about arrays in a second. But W3 schools is a great way to learn just syntactically how to use the language um, and go further than what we're doing right now. Okay, back to the slideshow. Sorry, I'm jumping in and out a lot. So we wrote our first C program. Congrats, we did it. Now, conceptualizing memory is very important for understanding how C affects software security, or how, software security. Oh my goodness, fumbling words. Conceptualizing memory is important in understanding fundamentally why software can be insecure in the first place. And understanding memory can help us progress towards being able to solve more advanced challenges. So the first thing about memory that I like to tell people is you can think of it as contiguous space. So space that's in a row. It's contiguous, and it all has an address. So every place in memory has an address, kind of like these parking spots. So you can think of it as a big parking lot where all the spaces are numbered. I don't know, I hope you can see my cursor, but this space on the bottom left is 382, 381, 380. They all have addresses. And so when you park your car there, you know that your car got parked in spot 380 or 379 or 319 or whatever. They all have an address. And you can store something in them. In our case, parking lots store cars. But you can think of memory as storing data. So back when we were writing our program, we declare a variable. Say we declare an integer called a, and we set it equal to a value. We're actually physically storing that value in memory. So somewhere in your computer, there was a piece of memory that was allocated for that variable, and that value 4 was put in that parking spot. And then when our program ran and then completed, it got deleted. So think of memory, or at least I like to think of memory as a big parking lot with numbers that represent addresses that we can put cars in. And we know where they are because they're at a specific address. Okay. When I declare a variable in C, when I declare a variable in C, I can either make it equal to the value stored inside the parking spot. So I can either make it equal to Chevy Camaro, or I can make it equal to spot 380, and I can put whatever I want in that parking spot. So at one point, the value at that parking spot might be Chevy Camaro, but then the next day it might be, I don't know, Honda Sonata. Two different car models. And I'll always have that address. Or I can just set it equal to that specific value in the spot at one time. So, oh, I just duplicated that slide. That's why I was confused. Okay. So to access the memory address, so remember the number of the parking spot. So instead of getting the actual value in the parking spot, to access the memory address in C, we use the and sign. So you can see on line 14 and in our scanf example, so let's go back to a scanf. What we're doing is we're declaring a variable, and it's getting assigned a memory address. It's being allocated a certain amount of memory based on its data type. And so then when I pass it to scanf, it doesn't want the value of this. That's useless because it can't store a variable at the value of this. What it wants is the memory address so that it can populate the parking spot that's been assigned to this number variable. So we give it the memory address and it puts whatever the user enters into that parking spot. In this case, we entered 10. So it puts 10 in that parking spot. And then in the if statement, we use the actual value of the variable. So if 10 mod 2 is equal to 1, it's odd, else it's even. So yeah, so this and sign is equal to, once again, the memory address or the number on the parking spot. Because when we use scanf, we need to populate this variable. All right, same thing here. We declare an integer called a and set it equal to 7, and then we print out the memory address of a is %p, which stands for pointer. So in C, when we have these variables that store memory addresses, we call them pointers because they're pointing to a specific part of memory, or at least that's how I understand it. So we print out the memory address of A is %p. That's the format for the type of pointer. And then we give it the and sign and then A, which we know the and sign gives the memory address. Sorry if it feels like I'm being repetitive. It's just that pointers and memory addresses can be hard to conceptualize if it's your first time hearing about them. So don't feel bad if you're not picking this up immediately. It will take some practice to get used to. But just remember that what we've printed out, so this is the memory address. This is a big long hex number because memory is a big place. So we have this big long hex number that represents the actual memory address of where this value 7 is stored. So it represents the parking spot in our massive parking lot of memory where the actual value 7 is stored. So why is this important? Well, because if we understand this, we can start to understand how control flow in a program works a little bit later. We can also understand how different arrays work. So I'll get to it in a second, but this parking lot metaphor is good to understand actually how arrays work. So memory. To declare a variable that only stores a memory address, once again, we use the asterisk. So in line 17 here, we declare an integer pointer. So it's going to be a memory address that holds the value of some integer. And then we set it equal to the memory address of a. So we declare an integer variable, so int a is equal to 7. And then we declare this pointer, or a variable that can hold a memory address, and set it equal to the memory address of a. And so then we print it out. The memory address P is storing is, the memory address P is storing is, yeah, that makes sense. The memory address, the variable P is set equal to is %P for type pointer, and then we give it P, the variable. So the memory address is this big hex number. Oh, a lot of talking, but pointers are very important to understand C and to write more and more advanced programs and get into more and more advanced data structures type stuff. So yeah, it's an important concept. But like I said, don't feel bad if you don't get it on the first time because it takes a bit to understand. So if I want to get the value stored at a pointer variable, I have to dereference it. So what I do is if I want to get the value stored at 379, I can just put an asterisk next to the variable that stores that memory address, and it will dereference it and give me the actual value. So the way to do that, remember I declare an integer variable 7, and then I declare a pointer and set it equal to the memory address of A. So now this variable P is holding the memory address of A. It's a pointer. And so on 21, I print out the memory address P is storing is this. So I print out the memory address just like in the last program. But then I can use the same variable to actually print out the value that's being stored inside that memory address. So on line 22, I put the value stored at P is an integer, so %D. And then I dereference it using the asterisk sign and then put P, the name of the variable. So the way to dereference a pointer is just to use it with the asterisk sign next to it, and then I'll get you the actual value stored at that memory address. Okay, so this leads us to arrays. Arrays are used like lists for storing multiple values at the same time. And in C, the way that they're implemented is you declare you declare an array, and then in this array, you can fill it with a bunch of variables and that populates memory. But the actual value, the variable of the array, is pointing to the memory address that holds the first element. So let me say that again. The actual array variable is a pointer to the memory address that holds the first element. So if we declared an array of size 5, right? And we set it equal to these 5 numbers on the parking spot. So 97654. The actual variable would be the address that 9 starts at, this value 9, since this is the first element in the array. So it would be 380 in this case, because that's the number of the parking spot. Um, yeah. And so then to get to the next value, I would know that I have to go a certain amount of space to get to where this 7 begins. So this is how arrays are implemented in C. And understanding memory can help us, use arrays. So what happens if I declare an array of size 5 parking spots, but I accidentally write to the 6th parking spot out of bounds of the space I have allocated? So maybe there's something critical stored over here. Well, in C, one of the ways that it's insecure is I can do that. If I'm a bad programmer and I do that, I absolutely can do that. Nothing is going to stop me. So there's no bounds checking natively in C, um, which is important because you can overwrite other data and totally mess up your program. And then a malicious actor could use that and exploit it and take control of your program. So there's no bounds checking in C. Yeah, but that's how arrays are implemented. It's the variable points to the first element in the array where it's stored, the memory address. Okay, so here's an example. We declare an array, int numarray of size 5, and then we fill it up with these random numbers. But this numarray variable is going to hold the memory address of the first value in the array. Okay, so this is a lot, but now we're going to write our second C program, which is a function that's going to take an integer array as an argument and prints out the memory address and value of each value in the array. So this function should also sum up the values in the array and return the sum. Okay, so we're going to print out the memory address and we're going to print out the sum of all the values in the array. So I'm going to actually exit out of here, go back to my online compiler, and use the oldest trick in the book, which is copying this code to get started, to defeat our blank page problem. So we declare an array, and then we want to iterate through it, right? So I'm going to use a for loop. I equals 0, I is less than 5, because we have 5 elements in the array, and we want to do each one, so we're only going to iterate by 1. So we have our for loop, and now what crazy thing did I do here? Num array at I is equal to I times 52 divided by 6 plus 256 mod 73. Interesting. I am not going to be able to remember that. I times 52 divided by 6 plus 256 mod 73. 73. Okay, so now I'm filling my array with some number that I'm quite literally too lazy to calculate. The first one is going to be 0, I think. But we'll see. Okay, so now I filled my array and I want to print out the sum. So I'm going to just declare another function here. I'm going to say it's going to be of type void because I don't want it to return anything. So I'm going to say void sum print, and I'm just going to take an argument of this array. So I'm going to say int a, well, let's just call it num array. So I'm going to take this argument of an array, and then that's it actually. Okay, still can't type. Okay, this does not look right to me. Let's see. Oh, this is good. Let's see here. How do we do arrays as arguments? Good Googling exercise. Oh my goodness. Oh, okay. I was right. Whatever. I just gotta put the size in there. Okay. That's a good lesson. I've been writing C for years now, and I forget how to do stuff all the time. So you can just give it a quick Google. Okay, so now we want to, what do we say we want to do? We want to print out, takes an integer array as an argument and prints out the memory address and value of each value in the array. It should also sum up the values in the array and return the sum. Okay, so we want to do another for loop. Int I equals 0. I is less than 5 because that's the size of the array, and then I plus plus. So we want to print num array. So we got to do format strings again, right? So %d num array at I. So I'm going to print out this integer. And then we also want to print out the memory address. So we're going to do printf. Thank you. We're going to do print %p. And we're going to do the reference of num array at I. And then we also want to get the sum. So I'm going to declare another variable called sum. And I'm going to set it equal to 0. And then sum plus equals num array at I. Okay, and then down here we can print out the sum is, and then give it the sum. Okay, I think this is going to work. We'll see. But I declare a function. It takes in an integer array as an argument of size 5 because that's how big our array is down here. And then I declare some variables that are equal to 0, and then I'm going to loop through my array. So for every time I loop through, I'm going to print out the actual value in the array. I'm going to print out the memory address that that value is at, and then I'm going to add that value to the sum and then print that out later. What I could do is I could do this because I am a fan of making things on one line, so I can do reference num array at I, and then I can just get rid of that. Perfect. And then down here, I'm going to go ahead and call this sum print with my num array. Shall we see if this works? Oof. Num array. Oh, this is because I did not tell it which element I wanted to um, set it to. Okay, that's another thing I realized I did not mention. When you have an array, if you want to access each value, so in this analogy, right, we have 1, 2, 3, 4, 5 values. So the first value is going to be the 0th index. And this is going to be the first index, second, third, and fourth. So 0 through 4 are going to be our index. So if I want to access this value 9, what I would do is I would use this and say I wanted to get the first element, it would be 0. If I wanted to get the second element, 1, third element, 2, 3, and then 4. Remember, we index by 0 in all things computer science. So this needs to be I because we're iterating through each element in the array. And it's going to go from 0 to 4 because we're going to do it while I is less than 5. And we start at 0. So it's going to do it 5 times for 0, 1, 2, 3, 4, which is 5 times. And we're going to print out and sum each value in the array. Okay, let's do it. Nice. Oof. I forgot to add new lines. Okay, so sweet. The first value is 37, then 45, 54, 63, 71. Then the sum is 270. So our program works. The order of operations there is probably a bit funky, but somehow we end up with these numbers, and we did it using the sum print function. So yeah, these are some pretty basic C programs. The point of this one was to, use some pointers, try and get familiar with this %p and then using the memory address here so that we can actually access the memory address instead of the value that's being stored. And you can see that this array is contiguous in memory because if you look down here, this hex address, we see DE0, then DE4, DE8, DEC, and then DF0, which is where all of these values are actually stored in memory. And you'll notice that it's all in a row because arrays are all in a row, just like in this parking spot when it's allocated. So, yeah, that's basically all I had for today. Just a very basic introduction into what C syntax looks like, um, and an introduction also into pointers, memory addresses, and conceptualizing memory to work towards a better understanding of, um, binary exploitation and reverse engineering. So thanks for watching. We're going to release more videos like this um, that are going to build you up to have adequate knowledge to be able to solve a basic buffer overflow. So these videos will be released weekly, and then they'll be on a series so that you'll be able to actually start um, doing basic binary exploitation, buffer overflow, learning about it. And maybe we'll do a series about reverse engineering, but that's more like assembly language type stuff and using tooling. So yeah, thanks for listening. We'll be back next week with another video, and um, happy coding and reading in C. Thanks.